Hey everyone, and welcome back to PrepFusion. So this is basically the extra part of the lecture 1 basically. I mean lecture 1A and B has been finished. So in this lecture we'll basically solve the questions. Okay. So yeah, basically this was the question that I gave you before, after studying the greatest integer function and the Signum function, right? So we have to plot this, right? We have to plot this function. So to plot the greatest integer of sin x, plot the greatest integer of sin x. So basically what is sin x? So if I copy sin x, right, to sin x, okay, sin x is just after this here, right? Sin x is just after this here. So if I just copy this graph, right, just copy this graph, if I just copy this graph, now what is the important point? So what was the greatest integer function? Basically greatest integer function means greatest integer less than or equal to x. Okay, so here, right, my x is sin x this time, x has changed to sin x. So at this point, what is the greatest integer function? This is something lower than 1. If this is something lower than 1, so obviously my greatest integer function is very brutal. It will directly drop it off to 0, so this, right, this is also something less than 1, so this will directly drop it off to 0. So in this, right, in this whole region it will be 0 only. But in this point, at this particular, when my x is pi by 2, it is exactly equals to 1, and the definition of greatest integer function is greatest integer less than or equal to x. So at this point my x is sin x is 1, so it is an integer, so it will be exactly equals to 1. For this particular single point it will be 1, and for the rest of this point it will be 0. So from 0 to pi we got our waveform, right, and it will be obviously periodic because my sin x is periodic. So greatest integer of sin x will also be periodic in nature. So now let's come to this pi to 2 pi. So what is happening to pi to 2 pi? So at this point, right, at this point, at sin pi is 0, and greatest integer function of 0 is 0. So this will not shift anywhere, right? Now at this point, what is happening? This is just below 0, If something is just lower than 0, my greatest integer function will directly shift it down to -1, because it searches the lowest integer, like next lowest integer after this, right? So the lowest integer after this is not integer, obviously this is something -0.1, -0.001, right? This will shift it down to -1. Okay, this will shift it down to -1. So this is -1. Okay, so if this is -1, so suddenly just after pi this is -1, okay, and this will go on till -1 until here, and suddenly like here, right, here, what is this point? This is -1, right? So sine of 3 pi by 2 is -1, and what will be the greatest integer function of that? That will also be -1. Okay, that will also be -1. Let me check if I am just talking, and if it is not recording, I'll be mad. Okay, yeah, it is recording. So the greatest integer of -1 will be -1, so that is fine. It will not shift anywhere. Then again, if I'm again my value is increasing again, right, this will shift this back to -1, so this will not shift anywhere else. Now again I come to this point, just at 2 pi. When I am at 2 pi, just below 2 pi, this will shift it down to -1. When I am at 2 pi, the greatest integer of 2 sin 2 pi is 0, because sin 2 pi is 0, so greatest integer function of 0 will be 0 itself. Okay, so that was the analysis, and this will keep on repeating. So let's plot the graph. Okay, let's plot the graph. So if I just draw the axes, okay, this is x and this is greatest integer function of sin x, right? So what did I tell you? What did I explain right now? So I explained that here, right, this is just above 0. If this is just above 0, but this is below 1, so this is this point, right, this part is between 0 to 1, so this will always be equals to 0 itself. So here, right, this will be always equals to 0. But one interesting fact is that just at pi by 2, this is equals to 1, right? So if this is equals to 1, that means the greatest integer function will be 1, not 0. So it will suddenly jump to 1 only. Okay, so at this point, this will be open circle because it excludes 0 and it includes 1. So this part, right? This part is 1. Okay, this part is 1. Now then, just after this, what is this point? This point is pi by 2, x equals to pi by 2. Just after this, my sin x is something lower than 1. So if it is something lower than 1, greatest integer function will directly pull it down to 0. Okay, so hence again we'll restart with 0 until pi. So this is the first half cycle. Now what happens? Just after pi, this goes to something minus 0.1, minus 0.001, right? So greatest integer function will directly pull it down to minus 1. So again, this point is included here. Okay, this point is included, but this point, this minus 1 point, is not included over here. Okay, but this will continue till 2 pi. Continue till 2 pi, and again at 2 pi, right? At 2 pi, again I will go to 0. Okay, again I will go to 0. Again I will go to 0, and this will continue again like this. Okay, again I will have an open circle. Let me just copy this thing. And again I will have an open circle. So what I can do is, I can actually do one thing. I can actually delete this thing. Can copy this thing actually. If I copy and paste this over here, then delete this thing, right? If I delete this thing, okay, this is the important part for me. Now again, if I paste this over here, if I copy this again, again for negative half cycle, right? Negative half cycle also the same only, so it will again be somewhere around here. Okay, here, yeah. So okay, I need to okay, so this will be this only. Okay, so yeah, this is how my plots will look like. Okay, let me delete this. This is what my plot graph will look like, right? So this is basically this is basically 2 pi, one complete cycle. Again, this is 5 pi by 2, not this. This is 3 pi only, and this is 5 pi by 2. Okay, so now this is minus pi, this is minus 2 pi. Okay, am I correct? Yeah, am I correct? So am I correct? Only a sine graph is like this. Yeah, sine graph is asymmetrical. Yeah, this is minus pi, and this will be minus 2 pi, and this will be 3 pi by 2, right? So yeah, this will be my answer to the first question. Let's go to the next question. Let's go to the next question. So next question is a Signum function of x into x plus 1, x minus 1. So this, right, this thing we have already done. Okay, just the difference is we have done this, we have plotted the exact plot for this, right? Okay, we haven't plotted Signum of this. So where is the exact plot? The exact plot is okay, why did I do, yeah, here, right? So exact plot is here only. Or we can take this, right? We can copy this same analysis. Okay, because I know where my function is positive and where my function is negative. So I know the locations of where my function is positive and negative. Just Signum function tells that only. Okay, it tells that only, that if it is positive it will give me plus 1, if it is negative it will give me minus 1, if it is 0 it will give me 0. Okay, so pretty simple. Okay, wait. So graph will also look something like this only, right? So graph will also look something like this. If I just try to make the graph. Okay, if I try to make the graph, this is something x and this is something y. Okay, and currently what we can say, so basically this part, right, after 0 this is negative. So for a negative value, like at this particular 0, right, it is 0 only. This at this 0, if I make x equal to 0, this is 0, so signum of 0 will be 0, so that is fine. Signum of 0 will be 0, fine. And let me mark this point, signum of 0 will be 0. And here also at x equals to plus 1, right, again this whole thing is 0, so hence again this will be again 0. This x equals to plus 1, and again at minus 1 also this will be again 0. So I marked the 3 points. Now after, just after this 0, right, my function is negative. So if my function is negative, I will get minus 1 point. So I will get minus 1. So I will start somewhere from here and until x equals to 1, I will remain at minus 1. Until x equals to 1, I will remain at minus 1, right? So this will be minus 1. Now just after x equals to 1, what is happening? This is becoming plus 1. This is becoming plus 1, right? So if this is becoming plus 1, so what will happen? So this is also not included over here, and I can write from here, right? This is becoming plus 1. And this will go on. This will go on. This will not end, right? This will not end, because it is always positive after x equals to 1. It is always positive after x equals to 1. Okay, and what is happening in the negative side? So when x is lower than 0, so for between minus 1 to 0 it is positive. So up until minus 1 to 0 it is positive. So if it is positive, the graph will look something like this, right? Just hold on. Oh no. So it will be something like this. Okay, and obviously there will be open circles here and here, because at like x equals to minus 1 it is 0, and then again less than x equals to minus 1 it is going negative. So if it is going negative, it will be somewhere around here, right? Somewhere around here. And it will keep on going. It will keep on going. Okay, so yeah, this is what this is, right? Let me just put this in here. Okay, I hope you understood the graph. This open circles, right? This open circles means they are excluded. This closed circle means they are included. Okay, so this is the graph of signum of x into x plus 1. So wherever this is positive, this is positive, right? Before 0, and after 0 this is slightly negative, then again this becomes positive, and wherever this is negative, this is also minus 1. Okay, that is what signum tells. Signum tells us about the sign of the signal, right? So yeah, this is basically it basically. So now let's go to the next question. Let's go to the next question, right? So what is the next question? So I gave you a few homeworks, right? So this was the first homework, right? So first thing what you notice is this a function? Is this a proper function? No, this is not a proper function, right? Because this is equation of circle. Equation, fine, but this is not a function, because for a function, for this equation to be a function, right, it has to have many to one mapping, but one to many can't happen. Basically a single value of x can give multiple outputs. It can only give single output. That is possible. Okay, so the curve by this equation is symmetrical about x-axis. When will it be symmetrical about x-axis? Okay, just try to recall. I gave you a few short notes, right? I gave you short notes. When it is symmetrical about x-axis, that means I'm replacing y to minus y, and they should be same. Just I think I give you a few key points, right? Give you key points here. If I here, if I replace y to minus 1, it should be symmetrical about x-axis. You can remember like this, that if I am replacing y to minus y, then it should be symmetrical about x-axis, yx. Okay, if I am replacing x to minus x, then it should be symmetrical about y-axis, xy. Okay, opposite thing, right? And if I am interchanging x and y, then it should be symmetrical about the y equals to x line. Okay, you can recall it like the rectangular hyperbola. Okay, and even odd functions, though, you already know, like odd function is symmetrical about the origin, even function is symmetrical about the y-axis. From here itself we do the same thing, right? For us to check whether the function is even or not, we simply replace by x to minus x, and then we check whether that condition follows or not, that f of x equals to f of minus x. That is what this thing is also saying to us. Okay, so is it symmetrical about x-axis? So for x-axis I have to check, I have to change y to minus y. It is symmetrical because if I change y to minus y whole square will be y square only, so it will be same only, so it doesn't matter. So again, this is correct. Which of the following options are correct? I should have written which of the following options are correct. I forgot to write that, sorry for that. I'm really sorry. Which of the options is slash are correct? Okay, so here, right, it is symmetrical about x-axis, so which is true, okay. Next is it is symmetrical about the y-axis. Is it really? So again, if I replace x with minus x, it will be same only, minus x whole square is x square only. So again, this is true again, right? Again, it is symmetrical about the xy line. Now if I replace the x equals to y, if I replace x with y and y with x, what will happen? This will be same only, right? This equation won't change. So again, this is also symmetrical about the line y equals to x. So I will just write few things, that replace y to minus y, then replace x to minus x, interchange x and y. Okay, then the last one, is this neither even neither odd? No, this is the even function, right? This is the even function, that we know because this condition is satisfying. So this is the even function. So this can't be neither even neither odd, it is a even function. This option is incorrect, right? So ABC is our answer. Okay, so let's go to the next question. So the next question is again interesting. It is a question of composite functions, right? So here g of x is given and h of x is given. We have to find g of x into h of x, which is simply a new function. Let's name this a new function as u of x. Okay, so I haven't written the options, so options something like options come up. Okay, I haven't written the options. So basically, how you solve this? So what you want to do, you want to put this g of x in the h of x, right? And but be careful that while putting this, right, is there any domain constraint over here? There isn't any domain constraint. X can take any real value, right? So like this portion can take any real value, that is h of x can be anything. So that is fine. So basically this will be 2 minus h of x u of x equals 2 minus h of x into what, h of g of x. So simply, is there any domain constraint over here? Yes, there is, right? This x can't be equals to 2. This x can't be equals to 2. So this g of x can't be equals to 2. So that is very important, that g of x can't be equals to 2. Okay, hence if this is equals to 2, that means x minus x will be equals to 0. So x can't be equals to 0, right? X can't be equals to 0. That is a very important domain over here, right? So this is basically g of x divided by g of x minus 2. Okay, g of x divided by g of x minus 2. Okay, so now how you want to solve this? What you can do, you can directly replace h of x and g of x with their particular relations, right? Equations of x. So here this will be 2 minus h of x. H of x is x minus 2, and this is simply what is this? This is, let me like take this arrow to the bottom side. G of x is 2 minus x again, so this is 2 minus x divided by 2 minus x minus 2. Okay, so this will simply be, if I just take this common, so this will be 2x minus 4 minus x. This is x minus 4 divided by x minus 2. This is into 2 minus x divided by, this is minus x, right? So basically this becomes x minus 4 divided by x minus 4 divided by x, okay, which is equals to 1 minus 4 by x, where my x cannot be equals to 4. Okay, so u of x I can write, sorry, where my x cannot be equals to 0, where my x cannot be equals to 0, so u of x I can write 1 minus 4 by x. Okay, basically my x can take any real values except x equals to 0. Okay, except 0 it can take any real values, which I already proven here, Okay, so yeah, this is how you solve composite functions. Pretty simple. Now let's solve few transformation questions. So like I have already given you transformation, so this will like quickly give you a revision of what transformations we have done. So this is a graph, okay, and first thing what I am doing is adding 1 with this graph. What will happen? This will basically shift up. Okay, so let me just copy this over here. Okay, and let me do one more thing. Let me again copy this and let me delete the axes. Okay, so it will be easier for me to do everything, okay, but not for you. Okay, what I will do, I will just delete these markings, okay, and I will just copy the graph itself. Okay, so everything will be easier for me, not for you. Okay, you have to do it by hand. Okay, and please do it by hand, it will be helpful for you. Okay, so I will copy this. I will simply copy this. I will keep this aside. So what is happening, this will get shifted, okay, by 1 units above, right, above the x-axis, because I am adding 1 with this. So basically if I may delete this, how can I delete this? So this can be deleted like this. Okay, yeah, so if everything gets shifted above by 1, right, so this will be something like this. This will be something like this, because this point, right, this point, the lowest point was at -1, so the lowest point will reach to 0. Right now, if I can, lowest point will be 0. Okay, so yeah, like nothing fancy over here. This is the highest point will become 2 this time instead of it being 1. So let me extend this graph further actually, and let me make this more. Okay, so yeah, this is this thing. So now let's go to the next one. This is the first transformation, so let's now go to the next transformation. And yeah, now coming to this, right, this is 2f of x, y equals to 2f of x. So if y is equals to f of x, then simply we are scaling this, right, we are expanding this. So what will happen is that, let me paste this over here only, let me copy the axes only, if I may. Can I copy that? Okay, I can copy the whole. This is really Okay, what I can do is, yeah, I can do this, then this. Okay, not this actually. I have to do this. I can simply copy this whole graph, right? So simply what I will do, I will just change the y values, because y values are getting in change, right? They are getting scaled. Okay, the shape of the graph will remain same, just the y value are getting scaled. So this, I'm multiplying 2 with this, so this will become 2 and this will become minus 2. Okay, everything else will be same because shape is same, just the maximum upper and lower limits are changing because I'm multiplying the y values, right? So then next what I'm doing, I'm simply multiplying a minus 1 with this. If I multiply minus 1 with this, whatever was here, right, whatever was positive here, it will become negative. Whatever was negative, it will become positive. Okay, so let me just cut and copy this in the next page. So what I will do, I'll again copy and paste this thing only. Okay, not this only. So this will be negative and this will also be negative. Okay, and this will also become negative and this will become positive. This will become positive and this will be negative. Basically I'm multiplying minus 1 with this. I'm changing the sign of this graph. All right, I'm changing the sign of this graph. So yeah, this is one thing, and let's go to the next thing. So next is this, right? If I'm multiplying minus with the x, what will happen? It will just flip about the y-axis, right? About the y-axis, because whatever was negative, whatever like was minus x, it will become plus x, and whatever was plus x, it will become minus x. So like these values will be same and they will become different. So what I'm telling, basically x equals to minus 2, my value is let's say here, right, x equals to minus 2, x equals to minus 2, my value is 1. So if I multiply minus with my x, so it will become, now at x equals to minus 2, it is f of plus 2. So what is f of plus 2? It is 0. So it will become 0. So this will flip over here and this will flip over here. Basically I'm multiplying the negative sign. Okay, so nothing fancy over here. So what I can do is so basically this will be somewhere around here. Okay, what will this become? So I can simply draw this actually. Let me draw this. So okay, this axis will get shifted on this hand side, right hand side. This will get cramped over here. Okay, okay, so basically they will get swapped. So this side, what did I have? This was a sine wave, right? Like a sine wave thing. So this will be something like this only. Okay, and this will be minus 1. and then again this, what will this will be something like this triangular, and this will be this. Okay, this is x equals to 2, right? Yeah, this is x equals to 2. Okay, so -1 + 1 x equals to 2. Great, fine. So this is done. So this is how you flip about the y-axis. Okay, what is the next transformation? So we are doing the mod of x. So whatever is positive will remain positive. Not mod of x, we are doing the mod of f of x. So whatever is positive will remain positive, but whatever is negative, it will be just flipped along the x-axis. So that will become positive only. So this thing will remain same only. Okay, just the negative part will become positive right now. Okay, this had no use actually. So this is the 5th one, right? Everything is recording, right? I have to sometimes check everything is recording or not. Yeah, this is recording. So this will become positive only, right? This will become positive only. So that is what this will change to, right? So this is simple only. Now next is mod of x. Now mod of x, what will happen? So I told you, right, the negative values of x will be deleted. The information will be deleted because this f of inside it, this can never go to negative. Okay, at minimum this can go to 0. Okay, so this f of inside can never go to negative. So this part is of no use to us. So this part is of use to us. So whatever is in the 0 plus 1 2, that will be in the -1 2, because this is mod of x. So -1, mod of -1 is 1 itself, mod of 1 is 1 itself. So those two things are same only. Okay, so basically the right hand side will be copied. Okay, right hand side will be copied basically. Let me copy this. And then obviously it will be symmetrical about the y-axis, right? Because whatever is mod of -x minus mod of -1 is 1, mod of, sorry, I am talking about, yeah, -1 mod is 1, 1 mod is 1. Okay, so those two things are same. So that's why it will be same symmetrical about the y-axis. So this also, let me just copy these points, paste this over here. Okay, what I will do is, okay, this can't be flipped. What I can do is, this thing is of no use. I can just simply replace this 1 and 2, right? Replace this 1 and 2, and yeah, this will be somewhere around here. If I just copy this thing somewhere around here. Okay, so I hope we got the point. So this, right, this mod of f of x will always be a even function. This will always be a even function. Okay, so yeah, we did all the transformations basically. Now let's do the final one, the homework one. So what I think is, I think you should do this for yourself. Okay, and like I will put this in the notes or solutions or somewhere. I may not. Some things you have to do by yourself. So this is pretty easy. You can do it for yourself, right? So that you can use your brain also. Your brain needs to keep on working, right? So yeah, this is for you to solve. So in the next lecture, we'll start with limits, which will be very interesting. Okay, from there questions mostly start coming from the calculus chapter. From there, right? This is the basics part. If someone has skipped their basics during class 11 and 12, they can watch this. Okay, limits also I will start from basics, then I will go to the next level. Okay, so yeah, thank you for watching, and I'll see you in the next video.